It was one of the scientific sensations of the year 2020. For the first time, evidence was presented for the existence of a parallel universe. As though that weren't enough, the universe was described precisely. It is said to have originated at the same time as our universe and to be a direct mirror of it. That means that, from our point of view, time runs backwards in the parallel universe. If you assume this theory comes from unserious tinfoil hatters or conspiracy theorists, you're wrong, because none other than NASA scientists have presented this sensational thesis. In this video, we'll give you all the information you need to understand the theory of the parallel universe running backwards. If you like our videos, feel free to support us with a thumbs up. Subscribe to Simply Space and stay tuned for more fascinating videos in the future. This is how our universe might have come into being. To understand the origin of the universe in detail, you would have to be a particle or astrophysicist. In all brevity, simply summarized, in time immemorial, there was very densely compressed matter. Then, there was a huge event called the Big Bang, in which those tiny particles that make up the entire universe developed from this mass within a very short time frame. These coalesced into larger formations, and our universe originated. Since this moment, the universe has been in a state of enlargement. That is, it is constantly expanding. The time span in which the universe developed is enormous. For example, it is said to have taken over 380,000 years for the particles to evolve to the point of being observable. This was followed by a seemingly infinite time of slow development. Our solar system originated a relatively short time ago, and is, in the meantime, more than 4 billion years old. As early as antiquity, philosophers wondered if our known universe was the only one. However, theories did not become more concrete until the 20th century, with increasing development of physical research. Specifically, researchers speak of parallel, namely, the hypothetical existence of an infinite number of universes similar to ours. This is, in fact, the only way otherwise inexplicable physical realities can be meaningfully resolved. A single one of these universes is called a parallel universe. The total or infinite number of universes is called a multiverse. These theories are mainly used in the fields of quantum and astrophysics. How these parallel worlds might look is usually the topic of philosophical considerations. It is assumed that there is an infinite number of universes, and that all of them have their own specific laws and natural parameters. If one assumes that our universe is the only one that exists, it would be the result of an incredibly improbable stroke of luck. Such conditions as ours are given in only the smallest percentage of all possible universes. Paradoxically, it helps if one assumes infinitely many universes have met exactly this lucky case. Then it's less improbable that we exist in one. These considerations are used as one of the most important arguments for the existence of parallel worlds. In addition, physical calculations have shown that further universes are not impossible, and only the impossible can actually be ruled out. NASA's current experiments bring us back to the starting point. At the beginning of this video, we told you that NASA scientists have found possible evidence for a parallel universe. It's now worth taking a look at the experiments that led to this conclusion. At the center of attention is the Antarctic Impulsive Transient Antenna, or ANITA project. This is operated by the University of Hawaii in collaboration with NASA. As the name suggests, the research is taking place in Antarctica. With the help of helium balloons, special radio antennas are brought up more than 20 miles above the Earth's surface to take measurements. Specifically, the focus is on inconspicuous, tiny particles called neutrinos. Antarctica was chosen because the air there is free of interfering radio waves and radiation of any kind, which makes the measurements more meaningful. The measurement of neutrinos is so interesting because they occur in large quantities everywhere in the universe. In addition, smaller and larger neutrinos can be distinguished. The smallest particles can move through all matter, which is why they can reach us extremely easily from the outer reaches of space. The larger ones, on the other hand, are stopped by matter and can therefore be used as a tool to locate planets. The usual measurements of the ANITA project thus include particles which come from space and smash into the Earth, producing short radio flashes. In addition to the neutrinos, numerous differently charged particles are measured, which also hit the Earth and thus produce radiation. The striking results of the ANITA studies. At an altitude of over 20 miles, these particles can be measured racing from space toward the Earth. They clearly move from top to bottom. Of course, they are joined by neutrinos which travel from bottom to top. This is because the smallest of the neutrinos are known to move through matter and can therefore pass through the Earth. What is impossible, however, are larger neutrinos, so-called tau neutrinos, that move from the bottom to the top, because these would have to pass through the Earth. But exactly this event could be measured several times during the ANITA studies. In rare cases, these high-energy tau neutrinos can cross matter. However, for this to happen, a strikingly large number of these particles would have to be traveling at the same moment, which could be triggered by a black hole, for example. If this were the case, however, other measuring stations would have to make similar observations, which was indeed checked and excluded. What remains as a possible explanation? There are two overarching possibilities. On the one hand, it could be a hitherto unknown form of neutrinos, for example, the discovery of new physical particles. On the other hand, there could be a problem somewhere in the complex system of measurements. For instance, the thick ice surface could have previously undreamt of effects, or the work was simply faulty. Only later was a third theory also published. This one is related to a paper on parallel universes presented in 2018. Researchers briefly summarize that physical processes are also theoretically correct if time, as well as parity and charge, are mirrored. From this follows that there is indeed the mathematically and physically correct possibility of a so-called mirror universe. In this universe, everything can run exactly like in our universe, only backwards and mirrored. That means that this universe, seen from our perspective, runs backwards in time. Seen from the point of view of this universe, of course, everything would be exactly the other way around. There, we would be the ones who move backwards in time. If particles are detected coming from an impossible direction, it could be that they come from exactly this reversed universe. Instead of flying toward the Earth, they race backwards through space and time. So, do the ANITA measurements now prove the existence of a parallel universe? The simple answer is no. It's not clear evidence for an existing parallel universe. Of course, this statement is followed by a but. ANITA measurements cannot be explained in any physical and mathematically correct way so far. The only concept which works with the results is that of the mirror universe. Assuming that the measurements are correct, and that all factors influencing them have been taken into account to the full extent, there are only two logical possibilities. First, it is possible that new particles have been discovered or that a previously unknown behavior has been documented. This would result in a massive change in theoretical physics. Of course, it is equally possible that we simply do not yet know the physical law that explains these measurements, but this would also result in groundbreaking changes within the world of physics. Secondly, the alternative is that there is indeed a parallel mirror universe, and that it's possible for the smallest particles to switch between these universes. This is the only way to explain, with current knowledge, why upward-flying particles were measured at a place where it shouldn't be possible. This would prove to be unbelievable progress within the physical sciences. But it's necessary to trace the matter more precisely with further measurements. Before you rejoice too early, even if scientists succeed in proving the existence of a mirrored parallel universe, it will be impossible, from today's point of view, to travel to it. To explore your inverted twin from another world will therefore remain pure fiction. We remain nevertheless curious for what fantastic discoveries further research in these areas will reveal. Who knows? Maybe we'll experience the exploration of undreamt of worlds and entire universes. What's your opinion on the subject? Do you believe in the existence of an infinite number of parallel universes? Do you think it's possible that during the Big Bang, a mirrored image of our universe was actually created, one that travels backwards through time? And is this really confirmed by the ANITA measurements? We're eager to hear what you think, and once again are looking forward to lively physical, mathematical, and, of course, heavily philosophical discussions.